Hello. So, on the optimization of the functionality that or the workflow that corresponds to a student answering a quiz, where we have been testing with 100 students or 200 students for quizzes of 20 questions. Sometimes you need to change the functionality because of performance. It said to basically that's what we have done when it decided that to reduce the number of invocations from the front end to the back end, such that it's not necessary to send information every time a student selects an option. Okay, that was it was implemented that way. You change the code and it was running, but the users complained that sometimes the students just lose their questions, or if they need to restart from the beginning, so they lose their questions. And actually, that's not a good thing. So we have to decide, in some sense, to not to do that optimization. And what we have decided to do is no, okay, let's keep the front end decoupled from the back end and send an asynchronous call every time a student selects an option. Let's send an asynchronous call, so there will be no impact from the user, the student point of view, because basically just sends an asynchronous call, but we process this in the backend. But what we're going to do in order to be faster is that instead of changing this in the domain model, you are going to create a log that is in a table, so that we try to reduce the impact of writing this. Okay, so what is going to happen? So we change our script, our test script. I'm not going to show you the test script because basically there's nothing new there in terms of the way you use JMeter to program it, but you can look at in the master how it is. But the difference now is that in this case I'm doing running 200 students executing a quiz of 20 questions, and now they submit an answer. Okay, I will not look at the latency here. Okay, but I will discuss the latency at the end. But so they submit the answer, and then you conclude the quiz. So what is new here is basically these 4,000 invocations from the client to the server, and we are going to try to reduce the cost of doing it. So the first thing what we have done is in the front end. So when basically a student changes an answer, basically when it just select or deselect an option in the question, okay, what you do, we do a remote invocation and send this to the server. But we don't do a wait there. So this is really asynchronous. So from the sense of from the student point of view, just he selects and deselects and we send this. And now we need to process this in the backend. Okay? So the way you're going to process it in the backend is we just create a table. Okay? And this table contains all the information we want. And we are thinking about this information not in terms of a log, but in the future to deal with the fraud detection, which so we have information about the time is selected, we collect when it deselect as well, you register when they select as well, so we collect all this information. Oh, this is a simple table, and you define an index there by quiz ID, because afterwards we are going to generate a log from this and write this log in the comma separated value file that is generated with the results of the students. We generate this log there, and so in order to optimize, we want to look for all the registries, all the tuples that are here associated with the quiz. Okay, so nothing special here. Another thing that we have done is in the controller. Okay, so in the controller you invoke every time you submit an answer, you just invoke this, and you have a submit answer there. Something that we decide to do here is that you use read uncommitted, because this is not going to read any information, and actually it's just to do a write. We're going to do writes in this table, okay? And so let's not lock anything. So let's have these read uncommitted, which means read uncommitted means that if there's something that is written there by a transaction that was not yet committed, we don't care. But so let's keep the locking really, really weak, such that we don't have contention related with that. And then another thing that we've done, we are going to insert. So we optimized insert. We are not going to use anything about a domain model. You're going to write an insert on the table. So the only thing we do here is basically you go to the repository and we define in the repository these, okay? There are two because they need to deal with null and not null, and you have a native query where you do an insert. So we want to optimize this, okay? And this is the query where you select them just to generate afterwards the log and the CVS file, okay? On the CSV file, okay? And you can find it basically here, the code, in the CSV file where you have the list of question answer items, this list, and basically you write these in lines, okay, that then will be in the final, in the file, okay? So let's, just to finish, look at performance here. And in terms of performance, things are not nice, okay? Because now for these students, of course this occurs offline, but it has an average latency of 11 seconds, okay? So you still have some problems here, and we had some concerns why, although you have a throughput of 15 transactions per second, you are just writing on this table and basically you are doing nothing. So where is the problem? And how we identify this problem and are going to solve it is the subject of the next video. Okay, see you in a while.